Okay, exploratory vector analysis, EFA. The purpose is a test for the underlying structures among variables. Let's say given 10 variables, you want to know what are the underlying structures among the variables. Sometimes call it dimensional testing for dimensions. So sample size, it is 100. Things to do, administer questions on the same target population as you did for your pilot study. No changes made in the pilot, the cases can be considered. Perform factor analysis on the item, construct by construct separately, don't put all together. Now to note, method, principal axis. The default is principal component. Again, about 80% of the articles published, they have used principal component instead of principal axis. So principal component is not the right thing to use. All right. Okay, remember, later in the SPSS, the default is principal component, we change to this. If at all more than one factor within, then yes, rotate. Use oblique, not very much. Your items are negatively worded. It's not necessary to recode, but you want to find the average, then you have to recode. Right, look at these indicators. It's called latent variables. Latent variables are not measured or not observed. Example, customer satisfaction. We can't measure directly, it's latent. It's somewhere inside the head, right? It's not real, latent. How do you measure that? We ask questions. So these are questions in the questionnaire. The way the person marks here, right, based on what he marks here, we start to establish this. Example, 5 questions here. 1 means dissatisfied, 5 means satisfied. The person gives all 5, 5, 5, and 5, and 5. This means the guy is very satisfied. Another guy gives responses 1, 2, 1, 1, 2. That means the guy is not satisfied. So whatever satisfaction level is contained inside the head, you bring it down on a piece of paper. The way they mark respond to the items, we're able to tell what inside the head, which is latent. So these indicators are known as reflective indicators. Reflection of what inside the head. So the method must be principal axis factoring, not principal component. So what's the basic difference? For this, these are the dependent variables, arrow ends. But for this, these are independent variables, arrow exits. Most questionnaires are of this kind, reflection of what's up there. Very rarely we have this, right? Example, before going for holiday, you may ask people, how's the environment, how's the room, how's the food. Based on information gained, you may have a picture of the destination, the hotel. So these are called formative indicators. So this class, you can talk only about reflective indicators. Right. What to look for? Again, this is important, same like just now. Standard deviation must not be 0. Pairwise correlation must be between these two. 0.3 and 0.9, we went through earlier. Now, new measures, Kaiser-Meyer-Olkin. This value must be at least 0.7. This tells you whether data is reducible, right? Can be made into smaller dimensions. Number of factors, how many factors we are looking into dimensions or factors. How many factors? And the average variance explained. This is a factor loading. You're going to look at all this and see whether the items, how many dimensions is one or more than one, and make conclusion. Okay. So to explore again these variables, we follow this and bring in these variables inside, and the descriptive, you can ask for correlation and KMO. So these two, you must select. It's not default, right? Coefficient, we check the correlation between 0.3 and 0.9. KMO, we check at least more than 0.7 for these two. And then extraction, the default is principal axis. Remember our variables are reflective indicators. So change this to one of the others most often used is principal axis factoring. Later use MOS or something like that. They use principal axis factoring, right? So that's all. Bring the variables in. Under statistics, click this 4. Under extraction, change the method extraction. Right, tables. Number 1, you can see all the standard deviation of more than 0, fulfill. Number 2, the highest correlation in each column between 0.3 and 0.9, covered. Kaiser-Meyer-Olkin, value is 0.799, more than 0.7. And then in table, total variance explained. And look at this table. On the left-hand side, there are 4 rows. On the right-hand side, only 1 row, which means the 4 items can be reduced to 1 factor. That's called number of factors. This, how many items? 4 rows. Here become 1 row. That means all the 4 items can go into 1 factor. And that's like your R square, That means a single factor can explain the variation in the 4 items. The single factor, like what you talk about here. This single factor, right, can explain 60% of variation in this item. Remember, this independent, this dependent. How much the dependent can be explained F1? So we have 60%. Ideally, this must be more than 50%, but some researchers want this to be at least 60%, right? Ideally, some research want this to be at least 60%, right? So that's covered. So how many factors? 1 line, therefore 1 factor. Now, these are called factor loadings. These are the regression coefficients. Remember this diagram? This one regression, another regression, so regression coefficients. That means the value of slope, all are standardized. This to this, and so on. So these are the coefficients, 0.84 and all this. So you want the value, minimum value must be at least 0.5. So I keep this. How to get this value? We square all these values and average it. Can you do that? Square all these values, add up and divide by 4. Somebody try this? Everybody trying? Dema?
Yes.
Right. Okay, roughly, right? 0.8 square, 0.64, 0.64, 0.64. There's about 0.36. We average this, you get this value. Can somebody try? Square these values, add and divide by 4. Should get this value. Right? So get these values. Supposing these values are small, for example, 0.2, 0.2, 0.2, and 0.2. So 0.2 square, 0.04, average only 4%. If these values are small, this is going to be small. So this small means they are not good indicators. So we'll see from here, the correlation will be low, this will be low, this value is below, and this will be low. That means not good. The 4 items are not good indicators of remuneration. Right? So that's what I look for. Reporting the results. We report construct by construct. There are 4 items in the construct, descriptive statistics, inter-item correlation. So these are descriptive statistics. Right? The values are 1 to 5. 1 to 5, the midpoint is 3. You can see all the values, most of them below 3. That means they're not very happy with the remuneration. And look at the correlations. The highest values are between 0.3 and 0.9. So write this way. Maximum correlation, this and this, correlate adequately. The exploratory factor analysis, KMO value was 0.799, 0.799, which is more than 0.7, considered good. How many factors? There were 4 factors, 4 variables. They are reduced to 1 factor. How much does it explain? 60.8%, that's very good. The minimum factor loading is 0.570. Right? So normally what you do is, for further analysis, you find the average of the 4 items and save it for further analysis. Right? Save it for further analysis. Right? So how to save? Let's do this first. Let's do the analysis. Data is data for factor analysis. Right. Data for factor analysis. Just follow through and see how your last assignment is going to be. So follow the steps. Analyze dimension reduction. Older version SPSS we used called data reduction. So now they call it dimension reduction factor. The others are for qualitative variables. These for quantitative variables that are defined in terms of numerical values. So bring the variables in, right? Under descriptives, choose univariate, coefficients, and KMO. Continue. Extraction, change these to, you can use maximum likelihood, principal axis. So here I'm going to use principal axis. That's all. So the extraction method based on eigenvalues more than 1. So I'll tell you what's eigenvalue of this. Continue. Okay. So look at the results and compare your notes. Standard deviation all more than 0. Minimum correlation between 0.3 and 0.9. KMO value 0.997 is good. From this total variance table, 4 rows become 1 row. That means 1 factor is extracted and explains 60% of variation in the 4 items. How to get this value? So these are the factor loadings similar to correlation regression coefficients. Square all these values and average. That's the one here. If some values are low, then this value is going to be low. Right? Maybe I show a variation. Right. This concept of eigenvalue. Definition eigenvalue is explained over unexplained. Linear regression, explained over total. That's called R square, explained variation. Here the eigenvalue is explained over unexplained variation. Can you add this up? How much we get? Add these values. This total, can you add up the values? What's the value? Answer? Add all this, what's the answer?
4.
4. So don't have to calculate. There are 4 items here. So the total is 4. Now, the one factor here, 2.788 out of the 4. Do 2.788 divide by 4. 2.788 divide by 4. How much is that?
Zero point
Yeah?
697.
0.697. This is the one. That's called eigenvalue. That means the one factor explains almost 70% of the variation in the 4 items. So total 2.788 out of the 4. Eigenvalue is 2.88. Total 4. Out of 4, 2.788 by the first factor. That means it is 69.69. Eigenvalue more than 1 means more explained, unexplained. This all less than 1, less explained. Eigenvalue 1 means as much explained compared to unexplained. Eigenvalue more than 1 means more explained than unexplained. That's what you want here. That's why the method says eigenvalue more than 1. So one factor, how much explains? Now these are corrected for, okay? These are corrected. This is before correction. This after correction. We report the one after correction. Right? So we conclude. Everything's okay. We write out. Results from factor analysis is for remuneration construct. Because there are going to be a lot of other factors, you can write there remuneration. Okay, remuneration. For remuneration, we have, okay, just tell how many items. How many items there? And then do the descriptive, show the table. The table must have heading and describe. You don't have to describe these two. Looking at this, we know there's no 0 standard deviations. Most of it less than 3. I mean, people not very happy. What's important is the correlations. You are between this and this. And then what's your KMO value? And how many factors extracted? Single factor. And how many percent explains? And then what's the minimum? Factor loading. So once you've done this, look at the last part. The mean of the 4 items are computed. Okay, watch this. Transform. Transform. Compute. So give a name. Give a name, enumeration. Here, mean, MEAN, it's not case sensitive, upper, low class. Bracket, double click 1, space, TO, space, double click. That means you already have the mean of these 4 variables. So functions mean, mean 1, so space there, 2 is 1 here. So it finds the mean of these 4 items. Continue. And look at the data, last column. That's a score. Okay, this score, the guide 4, I'm going to bring this variable closer to the raw scores. So easier to see what kind of transformation taking place. Yeah, bring it closer, you can see. All right. So this guy, 4, 4, 4, 4, the mean is 4, right? So 4 we know is towards satisfied. Look at this guy, 2, 1, 2, 2, 1.75. So 3 means neutral, less than 3. That means the person is not satisfied. So you can see this guy is not satisfied, right? This guy is satisfied. So highest score means satisfied, lowest score means not satisfied, right? So factor analysis is not the end. So it means for other analysis. If I move it here, now what do I want to know? What do I want to know? Let me change the name, okay? Remuneration. All right. If I give a data something like this, what do you want to know? Have you done this before? Have you done analysis based on data like this before? Guys?
Yes.
What analysis? What's objective? What's objective here? Remember, yeah, so your final project going to be something like this, okay? What do you want to know?
To test the factors of remuneration.
Again?
To test whether gender, qualification, or income and length of service associated with remuneration.
Right. Factors associated with remuneration. Are they qualitative or quantitative factors?
Qualitative.
Qualitative. This variable
Qualitative.
quantity.
Gender quality.
Huh? This
Quantitative.
quantity or quality?
Exception rate or other quality remuneration quantity.
This quantity got decimals all. This quantity.
Yeah.
It's all quality.
Yes.
So what analysis is going to do? What analysis? What analysis? I went through so many analysis. It's going to be general linear models. Remember last time I talked about SBP versus qualitative variables. So remunerate, dependent, all these variables are fixed factors. The quantitative variable go into covariate, fixed factors. Go and check the notes, okay? Model, build terms, change to main effects.
My effect.
Yours different than mine, right? Change it accordingly. Right. Are you all getting this? Continue. And click OK. This table important to look at the number each group is sizable. So this also will help to produce a table later. table demographic variable. You can copy and paste and form the demographic variables from here. Okay, look at this table now. Which variables are significant? Only these variables, right? So which variables are significant? Is gender significant?
Yes.
Yes. Qualification?
No.
No.
Monthly income?
Yes.
Yes. And length of service?
No.
No. So you're going to have a table like what we did in your, let me open the file. What you did under general linear models. Under general linear models. Right. That's any of the results. So this will be remuneration, and this will be all the variables, the values, and then write up the conclusion. Right? So this variable is very important. First, you must write the demographic variables. Tell us who's the respondents. I can copy this and paste it. Okay, these are demographics. It won't take that long, right? And prepare the table. Maybe this may not work well. You can go to Excel and paste it. Right. It's male, female. Based on that, you can find the percentage. How do you find the percentage? We know the total number. How much total number? These two add together how much? 30308. Total 308. So what's the percentage here? 140.84 divided by this value 308 divided by 308. 308. So that's 59%. And then drag down. So you do a demography. Then you can type inside. There's how many percent there? 60%. So you can create a demography table just based on this. Right? But for reporting our results now, so that's the N. Here I'll talk about mean and standard error. We report mean and standard error for here. And then put a p-value there. Okay, let's see how to fill up these values. We don't need this. It's only for demography. See how fast the whole thing can be done. So I expect your final assignment to be fast. Okay, let's do the analysis now. Fill out the mean tables. I already have only the mean and standard error. How do you do that? Univariate under EM means. Some don't have EM means, go to options. So under EM means, bring all the variables in. And then compare means, as you mentioned earlier, Bonferroni, p-value. Continue. And click OK. It's not just revising, okay, what you done earlier. Right. So look at the mean values. Okay, check the p-values first. What was significant? Let's plug in the p-values first. What's the p-value for gender? What's the p-value for gender?
0.038.
0.
038.
0.0, right? Sorry, 0.036. 0.036. 38. All right, next one. Education, 0.806. Next, income, 0.004. Next one, years of service, 0.298. So from this table, we plug in the p-values. Now, when it says there's a difference, you must tell how they differ. So for that, we need a mean and standard error. So what's the mean here? Gender. Whether significant or not, you just put the values in. 2.88 plus minus 0.802. 7. Hold on. All right. What's the value? 0. 2 point. Gender, what's the value? 2.880. Standard error. Okay, that's the value. Female, 2.658. This is 0.093. So there is significant difference. So later you're going to write how they differ. So we're going to say among the tested variables, which variable is significant? Only gender and income are different. Only gender and income. Income are significant. Then how you have to express this now? So who's higher? The mean scores for the males was higher. Use past tense, higher compared to the females. Compared to the females. Right? Who are significant. Next, income. Again, fill out the values. Let's see income. How does the income make a difference? So go to income. Degree. Okay, monthly income. So write the values first. Which pair is different? I can say more than 4,000 different from these two. More than 4,000 are more satisfied compared to these two. 4,000 minus this is positive. 4,000 minus this, positive. So those earning, maybe these are the managers, those earning more than 4,000 are more satisfied by the others. So vector analysis is not the end, so it means for further analysis. Right? Are we clear?
Can I ask you a question?
Sure.
Does explorative factor analysis similar to the validity test?
No. Validation is much more. Exploratory factor analysis, until exploratory, from pilot test to exploratory, you can only say psychometric properties, sufficient psychometric properties. EFA is not validation. yet. Must go one level higher to confirmatory factor analysis. Then we talk about validation. Ahmad, am I okay?
Yeah, thank you.
All right. EFA only looking for the dimensions within. How many dimensions? Is it one or more than one? So, did you write up? You did mention this earlier. So it's exactly what we are doing here. But before that, you must report the results from here. You must report this first, follow up with this. Are you okay? Class, are you okay?
Okay.
Now go to your data. Go to your data. Data for factor analysis. Data for factor analysis. All right. Let me remove this. For the last column, I already have this plus this. Perception of remuneration already done. Remuneration. How do I do this? I run the whole analysis. I'm going to go on this analysis fast. Factor analysis, remuneration. I'm checking the dimensions. Okay, job challenge. Click OK. Check this, check this, check this. All okay. And I complete only one factor. One factor extracted, but this value is small. Only 40% explained. Is it small?
Yes.
Yes. So what does it mean? Check the last table. Any values less than 5, all the values are still more than 5, right? Correct?
Yes.
Yes. What do I do? I'm going to drop 1, which is the lowest value here. Which is the lowest value?
CD2.
CD2. So go back. Why I'm not happy with these values? Look at the correlation values. Even though more than 0.3, some are not very good. So this I'm not happy. Minimum 50%. Right, 60%, but bare minimum 50%. 60 is ideal. So we're going to drop among this is smallest, CD2. So drop CD2. Run again. Let's check. Still less than 40%, less than 50%.
Yes.
We're going to drop the CD1 because the factor score is not good. Drop CD1. See, we're just exploring. We're not confirming, only exploring. When you only 2 items, the KMO is always 0.5. Don't worry. 2 items, KMO always 0.5. Now, at least 50% explained. Right? So here, instead of 4 items, I'm going to go with the 2 items only. Right? Let me remove all this. Let's do all over again. Okay, remove all of you, remove all this. Remove the last columns. All right. Let's start all over. Transform. Compute. First, remuneration. Remuneration. Factor analysis, we found all 4 items okay. Click OK. Right, this is the score for the 4 items. Second one, job challenge. Okay, job challenge. No space, Which items? Dhamma, which items?
That was career development, not job.
CD3, you put a comma, CD4, only the two. The other two were not good in the construct. Just two items, you can put a comma. More than two items, then use a two. Click OK. Okay, that's a score for job challenge. Next variable. Let's do the factor analysis. Factor analysis. Again, for this, you're going to write this, right? You're going to say initially only 40% will explain, right? 40% will explain. Then you dropped items 1 and 2 were dropped. Right, because not enough. Then you continue. All right, so now you're going to JC. Okay. Okay. It's okay. KMO is okay. Okay, single factor extracted. Factor loading. This is less than 5. If I drop this, this is going to increase. So drop this. JC1. JC1 does not fit in well with the others. That's why this is very low. Okay. Now you can see KMO, more than 0.7. Single factor extracted, almost 60%. So that's good. So you're going to say, we drop item 1, then the AVA, where is extracted, almost 60%. So we score all this in average, that'll be that value. Now, find the mean value. I think it's job satisfaction, right? The job dot satisfaction. Mean for the 3 items except for, all right, 2, 4. 3, 2, 3, 4. Right? That's a score. And last one. Last one. ITL. See, as I go, I drop whatever not necessary, write up, and then do the total final sum. Okay. All look okay. That's good, 61%. You can see all are more than 0.5. So it's like the first one, remuneration. And then do the, so this is ITL, intention to leave. That is mean of ITL 1, 2, ITL 4. Close. Now we have these 4. If you look at my, what I started initially, my objective. So that's my objective. I took out 1, okay? I took out 1, create advancement. Right. So I can't remember which one I took out. Doesn't matter, all right? Just leave it there. So we have remuneration, job challenge, and job satisfaction. So with this, I want to know what are the factors associated with this. If I follow this, what's my analysis? What is my analysis?
Multiple linear regression.
Again?
Multiple linear regression.
multiple, linear, whatever learned earlier, they become useful now. Now, which is the dependent variable?
Intention to live.
Intention to live, right? Intention to live is an independent variable. So do regression. If you're not sure, go and check your notes on regression. Right. Analyze, regression, linear, dependent, ITL, independent, these three variables. See, all these are latent actually, computed the values. What else we do? For the plots, always do this. Predicted x-axis, residual y-axis, always. Residual, predicted. So this will give you the residual plot. Continue. Here, check for multicollinearity. What is 36? Multicollinearity diagnostics. Continue. Then you must check the assumptions on the residual. Safe, unstandardized residuals. Continue. That's all. This is why you learn the whole day in one of the classes on regression. So now it becomes very handy, the analysis. All right. First, ANOVA table. In the ANOVA table, the p-value is less than 0.05. Therefore, ITL depends on at least one of the variables. Which variable? We go down here, only on remuneration and challenge, not job satisfaction. Multicollinearity, all less than 5, clear. R square, only 14% are explained. 14% are explained. Right, make it 15. Balance 85% not explained by these variables. Is it good or bad? It's up to you to interpret. And write the equation. This is the initial equation. Before we're doing the stepwise, check the assumption. This graph, does it look random? Is it more or less random?
Yes.
Not too bad. Now let's check the residuals, which is saved. Analyze, descriptive, explore. See, whatever learned earlier, all are useful now. Residual, plots, normality plot with test. Continue and click OK. Look at the values. We use Kolmogorov-Smirnov because sample size is large, more than 50. P-value less than 0.05 is not normally distributed. However, the skewness value is less than 1, less than 1, right? And let's check whether any major outliers or extreme values. Check the box plot. In the box plot, we don't see any major or outliers. So even though it's not normally distributed, we can still argue that there's no major outliers or extreme values. The skewness value is less than 1. So the data can be assumed fairly normal. For a sample size of 300, no major outlier extreme values, we can make inference based on the skewness and kurtosis. For a sample size of 300, if the skewness value less than 2 and the kurtosis value less than 7. So what do? You check the histogram. There is some literature on this area. Right, check the histogram. Or just now we saw the box plot. So you're assessing normality of the residuals. Look at the histogram. It's not too bad. It's not skewed. Look at the box plot. There's no major outliers or extreme values. In this kind of situation, sample size more than 300, if skewness value less than 2, kurtosis value less than 7, don't say normal, the residuals are fairly normal. So our conclusion now, still valid, our regressions are valid, except for, where is it? Right, except for this variable is not significant. So now, the final analysis, we can run the stepwise analysis. Let's see what happens. Stepwise, and let's see what happened to job satisfaction. So only 2 steps, job challenge and remuneration. So in the stepwise regression, only these 2 variables are significant. Only these 2 variables. Right? Step 1, job challenge. Step 2, remuneration. Only these 2 variables were significant in stepwise analysis. Right? So now the coefficients, both are negative. Means what? Higher job challenge, lower intentional leave remuneration, higher perceived remuneration, lower the intentional leave. That's good. Right? They're satisfied. They find the job salary is okay. Most likely they won't leave. Then you write the equation as we did in our notes on multiple linear regression. I'm not going to go into show you how to write up all these already done earlier, the GLM or regression, how to do the write up. Right. Okay. First, put all 3, even though not significant. Explain whatever. Then, in the stepwise, which variables were significant. We already done this exercise before. And talk about the residuals. In this case, residuals not normal. I'll argue that for a sample size of 300, this residual skewness value less than 2, kurtosis less than 7, and no major outliers, extreme values. So this can be treated as fairly normal. So your final assignment is going to cover factor analysis, it's going to cover regression analysis, and also going to cover general linear models. Are we clear?
Yes.
All right. So as a practice, I won't give the assignment today. As a practice, you do this. I'll tell you what to do. You already done part of this, so you do the rest. Maybe I'll use this. Right. So what I'm supposed to do for this analysis exercise? Okay, data for factor analysis. Do you have that? So what are given? 4 constructs. 4 constructs. Remuneration. Remuneration, some more. Job challenge. One. Job satisfaction. Right, job satisfaction and contingent leave. So the objective will be our statement. So why do we study this? Right. A manager of a factory observed the workers do not seem to be motivated. Do not seem to be motivated. He heard from of them some of them that they may leave the company. So he wanted to study. He wanted to study the reasons. The reasons. From literature, he identified three factors that may contribute to ITL. These are four constructs. Right? Forget about the spelling. He collected data with using a questionnaire. Questionnaire to measure a perception on all four areas. Okay, so that's the data. Okay, data is given here. Okay, required. What you're supposed to do. Required. 1, perform factor analysis. Factor analysis for perform factor analysis. Perform factor analysis. Factor analysis for each construct and report it. Number 2, determine the factors demographic characteristics. Determine the demographic characteristics that are associated with each construct. Next, Find the association between remuneration, job challenge, job satisfaction with ITL. All right. So what do you do today? You read done the first part, perform, and then you done the second part, find the mean values and how to test this GLM. And then we done the regression, how to do this, right? You did all three. As a practice, you do all this, right? You write all this first, and then required, so perform one by one. Factor 1, factor 2, factor 3. Do the write-up same way as in the notes. For each, write this up. And then demographic, you do your GLM and report it for each one. This for enumeration and the 3 other variables. And finally, you perform your regression analysis and report results from regression analysis. Results from regression analysis. Okay, something like this. Right? So now you're combining your factor analysis, your regression analysis, and also your GLM. Right? So do the factor analysis first, report for each one, and then do GLM, second objective. Report this for each. This only for one variable. Each variable, report this, and then do regression. Are we clear?
Yes.
Okay, you do this as an exercise. The title will be in workers' intention to leave. The title of this exercise, workers' intention to leave. We do the whole thing. I think for master's thesis, you're almost there. Your master's thesis, you're almost there. PhD may need extra. So do as soon as possible. By this week, maybe tomorrow, day after, I'll send you your final assignment. So your final assignment, I'll be writing something like this. I'll give you the data set and I'll tell you what it's supposed to do. So that will be 25 marks, the final assignment. Only thing new today is only the factor analysis. Right? Only factor analysis is new. Otherwise, all the rest you already done many, many times. Okay, do this first, then I send you the assignment. Are you okay? Class, are you okay?
Yes.
All right, stop here for today. Say bye.
Bye, teacher.
Bye. Thank you.
Bye.
Thank you.